Well, good morning. Here we go. Another day at the Smart Energy Lab. I'm just going to check out the latest projects here, see what the team's up to. So we've been working on a few projects to do with integration of smart energy monitoring, and we're also looking at electric vehicle charging, but most recently upgrading our solar tracking system. So we've got currently one Arctech Solar 1P Skyline 1 tracker, and it's installed and working, got about 34 kilowatts of solar on that, and it's great. Produces wonderfully throughout the day with a very long flat generation profile because of the single axis tracker. But today we're doing some post work on the new SkySmart 1, which is their 2P tracker, 2 panels and portrait here, and it's a much taller entity. It's 2.5 meters to the torque tube compared with the 1P trackers, which is only about a bit over a meter to the torque tube from the ground. So there's some logistics that make working on a SkySmart 1 a little bit more tricky because you're working up higher, so you need to consider access to the motor, to the skew drive, and for connecting up all the torque tube connecting points. But we've got a problem. One of the posts that we put in wasn't quite straight, so it really matters to get them straight. Now here at the Smart Energy Lab, we don't have the luxury of one of those GPS controlled pole drivers. We actually had to use a large auger on the back of an excavator, and we didn't quite get the hole right. So today the task is to redo the hole, to fix this little incorrect alignment problem, which is only about 40 millimeters. It's amazing how little you need to be out before that torque tube won't rotate smoothly. After all, it's basically a 45 meter long shaft that you're hoping will be in perfect alignment. So it's very important to get those posts at the right height, in line, and also without any twists vertically in the I-beams, so that the brackets line up properly. Anyway, let's check out what the team's doing. Well, here we are, a very big hole in the ground. It turned out to be a large rock near the bottom of the post, which caused it to skew as we were driving it in. So we had to get a backhoe in to dig it out, and look, there's going to take many meters of concrete to fill this one in, but getting it right is what it's all about. And you can't just do a lightweight collar. These posts, these 2.5 meters out of the ground, 2.5 meters in the ground, are going to be supporting a huge sail area. The Arctech Solar 2P trackers here, the SkySmart 1, will have 45 meters long by 4 meters or over 4 meter wide array of solar panels connected to it. And that's a huge sail. You could sail a ship with a sail that big. So the anchor to the ground is really important. That's why they do soil testing and they do engineering before choosing the appropriate mechanism to attach. So normally these would be hammered in with a rammer. We could only partially hammer them in because of the local rammers weren't very big, and we had to do a auger pilot hole 1.5 meters deep and then ram the rest. But we hit a rock on this post, and as a result, as you can see, there's a rather large lump of concrete down the bottom there. So there's the enormous hole that we're filling with concrete. Now the post is in the correct place. Looking forward to getting this all covered up, and this minor hiccup, let's call it a bit of a nightmare, goes away, and we have a beautiful straight post at the right height, perfectly vertical with no twist. That's the outcome. Okay, let's see what happens next. So this is a case of second time get it right. This wouldn't have happened if we'd used pile driving equipment with GPS location, but trying to do this in a much more simple bush way with, using a theodolite, some string lines, measuring tape, and your eye to some extent. We did manage to get one post about 80 millimeters out of true. So that's what the boys are fixing today, is pulling this post out, repositioning it correctly, and then installing the torque tubes, tightening them all up, the skew drive, testing it, rotating it by using an independent power supply just to make sure that the torque tube does the full rotations required before we start putting panels onto this system. So this is the Arctech Solar SkySmart 1 tracker, which will have about 34 kilowatts of Longi solar 435 watt panels. It also will be a mixture, 50-50 mixture of monofacial and bifacial modules, and we'll see what difference a 2P tracker compared to a 1P tracker in exactly the same location with exactly the same mixture of panels of the same power rating has. And the shading options are pretty similar at this site, so it'll be a good comparison, the benefits of a 2P tracker over a 1P tracker. So that's what's happening at the Smart Energy Lab this morning, out in the paddock. But in the lab, we're doing something a bit different. We're working on an installation video for Switched In. Now, Switched In's a company which I've had a long association with since their early inception, and they make energy management and monitoring systems, software and hardware. And they're agnostic as to what they can operate with. So most of the major brands of inverters, for instance, and batteries, they can control or monitor. And that means they can do some pretty clever stuff when you aggregate that together in such things as virtual power plants or flexible export arrangements. So we're actually doing a test setup here and showing how to install with a Fronius Primo the Switched In droplet and using flexible exports. So let's check it out.